All right, we're learning how to write proof statements, and particularly right now we're going to be working with two-column proofs. These are called formal proofs, where we have one column is the statements and one column is our reasons. A little while ago, we did a paragraph proof, which is called an informal proof. Doesn't have any less validity than a two-column or formal proof. It's just the name that is given. And I like the two-column proof better, to be honest with you, than I do the paragraph proof quite a bit. So we're going to have two columns, a left and right. We'll have our statements and our reasons. Now remember, we're using deductive reasoning. So we're working with things. Our reasons are things like definitions and rules and facts and properties and theorems and postulates and things such as that. So we're asked to write a two-column proof to verify each conjecture, and we start here with some algebraic proof. It's something, the algebra we're a little bit more familiar with, and we are really accustomed to solving it as to the way we're going to do it in a two-column proof. What we're not accustomed to is writing down our property or our facts or our rules or our reasons to go along with each step. And so it makes it a little tedious, and a lot of students don't like it. But, hey, who cares? All right, so we start off with if 5x plus 1 divided by 2 minus 8 equals 0, and that's our given statement, then x equals 3, and that's what we're setting out to prove. So we start then with our statements and our reasons. There's our two columns. And we always want to start with writing our given down. So here we got 5x plus 1 divided by 2 minus 8 equals 0. And our reason for that is, well, that's what was given. Now, if we were going to solve this algebraically, and we look at that, then the first step we'd want to do is add 8 to both sides of this equation. And when we do, we've got 5x plus 1 divided by 2 equals 8. And what property did we just use? Well, we just used the addition property. So in other words, you can see that we're going about solving it like we normally would, and we're just having to write down our reason. Now, if I'm solving this, the next thing I'm going to do, since I got 5x plus 1 divided by 2 on this side, I'm going to multiply both sides of the equation by 2. And so now I got 2 times 5x plus 1 divided by 2 equals 2 times 8. And of course, that's the multiplication property. Now here's one that gets thrown into us a little bit. We're going to go ahead and execute this command. And once we do, we now got 5x plus 1 equals 16. And so what we did here is we wrote it using the multiplication property, and then we performed that operation, and we call that substitution. Now, just a little tip. Sometimes if you get stumped and you're not sure what to do here, what answer to give or what reason to give, a good percentage of the time it's probably substitution and you're just missing it. What you wouldn't want to do is write multiplication property twice. You wrote it that way and then you executed that command. Now, what am I going to do next if I solve this? Well, I'm going to subtract both sides of the equation by 1 with 1. And when I do, I've got 5x equals 15. And of course, that's using the subtraction property. And 5x equals 15. I want to isolate the x. Well, I'm going to do that by dividing everything by 5. And x equals 3. And look what we got. We're at our proof statement. But what did we do to go from 5x equals 15 to x equals 3? Well, we used the division property. All righty? Okay. Now, let's go look at another one that's a little bit more complex because there's going to be a bunch of variables involved. If the distance d moved by an object with an initial velocity of u and a final velocity of v is given by the equation d equals t times u initial velocity plus v final velocity divided by 2. And so there's our given, okay? This part of the equation, d equals t times u plus v divided by 2, that's the given. Then, and this is what we want to prove, u is equal to 2d divided by 2 minus u. I think that's supposed to be a v right there. I may have to go back in and change that from a u to a v. No, it's minus v over here. So anyway, by the time you see it, it'll be corrected. All right. So again, I'm going to have a 2-column proof. I'm going to have statements and reasons, and I don't think I wrote statements and reasons down at the top of each column, but just know that the left-hand column is the statement and the right-hand side is going to be the reason. So I start off with d equals t times u plus v divided by 2, which of course is our given. That's what we were given. Now, in solving this, I've got t times the grouping of u plus v over 2. So I probably want to divide both sides by t. So then I've got d divided by t equals u plus v divided by 2. And so what property did I use? Well, of course, I used the division property. All right, now, if I want to solve this, I want to get rid of that 2 in the denominator on the right-hand side. So I'm going to multiply both sides of the equation by 2 to clear out that denominator. So we got 2 times d over t equals 2 times u plus v over 2. And what property do we use? What are we doing? We are multiplying. So we use the multiplication property. All right, now, that's going to result in, remember, now look, again, I'm executing the command. So I went ahead and multiplied the 2 times the d over t, which resulted in 2d over t. And on the right-hand side, I went ahead and executed the multiplication property of 2 times u plus v over 2. And the result was u plus v. And think back what we did just a moment ago. That's substitution. So again, if I get kind of stuck there and I go, well, I don't know what we multiplied again. No, we substituted. All right, let's see. Now we're trying to find our answer. So I'm going to subtract v from both sides so that 2d over t minus v equals u. And I'm pretty close to proving what I'm asked to prove. But what property did I use to get here? Well, I subtracted v from both sides, so I got the subtraction property. Now, in order to get this in the way that it asked me to prove it, I need to flip it around. Rather than 2d over t minus v equals u, I need u equals 2d over t minus v. Well, that's simple enough to do. I can just flip that around, because if a equals b, then b equals a, and that's the symmetric property. And shazam, we have done the 2-column proof.